Hello students, welcome to my YouTube channel Easy Mathematics. In this video, we are going to learn about D'Alembert's ratio test. Previously, we know what is comparison test and how to find out the divergency or convergency of an infinite positive term series. Now it is the time for D'Alembert's ratio test, but you should remember to do D'Alembert's ratio test or to apply D'Alembert's ratio test, we should know this comparison test quite well, because almost in all problems we have to apply this comparison test also. So anyways, at first start with the D'Alembert's ratio test and its statement. What is it? If summation n is equals to 1 to infinity un is a positive term series such that limit n tends to infinity un plus 1 divided by un is equals to L. Un is the nth term of this positive term series and un plus 1 is the n plus 1th term of this series. If we take the ratio of these two and after that if we take the limit when n tends to infinity, then we will find out a limiting value. So this limiting value is say L. If this L value is less than 1, then we say the given series is convergent. If we find this L value is greater than 1, then the series is divergent. And if by chance we find out that this value is 1, then it is the further analysis required, or we can say the test fails. Further analysis required means the series may be divergent or convergent for this value of L is equals to 1. Here one thing should be noted that the test, this one, the D'Alembert's ratio test, is also called the Cauchy's ratio test. The same thing. Actually we have taken here the ratio un plus 1 by un. That's so why it is called the ratio test. And not only that, one more form for the D'Alembert's ratio test we can be apply here. That is the instead of the ratio un plus 1 by un, if we consider the ratio un by un plus 1, then also we can find out or we can conclude about the series that this time just the conclusion be reversed. That means now if we consider un divided by un plus 1, then its limiting value corresponding to that, if L is greater than 1, then the series is convergent, and if L is less than 1, then the series is divergent. Okay, and definitely if L is equals to 1, then the test fails and we require to go for the further analysis. So this further analysis we supposed to apply the comparison test. Anyways, the inventor of this test is French mathematician Jean-Louis D'Alembert, and this proof for this D'Alembert's test you will find out in any standard book. That's why I am not going to give you the proof of this one. Rather, we discuss some problems so that we can understand the method quite well. Okay, so first question is, the series is given as 1 square by 2 plus 2 square by 2 plus 3 square by, it is 2 square plus 3 square by 2 cube plus 4 square by 2 to the power 4 likewise. So here the nth term is n square divided by 2 to the power of n. So whatever be the series is given, our first target is to find out the un. So un is here n square divided by 2 to the power n. Now definitely un plus 1 is n plus 1 square divided by 2 to the power n plus 1, just by replacing n by n plus 1 in this un. After that we should find out the ratio of these two. So ratio of these two means un plus 1 divided by un is equals to, we just substitute these two terms and simplify, so that we will find out it is 1 upon 2 into 1 plus 1 upon n its whole square. Now if we take the limit on both sides, then we will find out this limiting value is half, which is definitely less than 1. As the value is less than 1, so we can say by the D'Alembert's ratio test that the given series is convergent. So that is so very simple. So let us do for the next one. So next example is given, suppose this one. So here the question is n cube divided by n factorial, its summation, the series is given this one. So definitely its nth term is n to the power n divided by n factorial. Usually we should find out un plus 1 at first, and that is n plus 1 divided by n plus 1 its factorial, and definitely its power is n plus 1. We just replace n by n plus 1. Now we take the ratio, and after simplification we will find out this one, and when we take the limit n tends to infinity on that, then we will find out it is n plus 1 by n its whole to the power n. That is, we can write 1 plus 1 by n to the power n. That is the formula, which is e. Its limiting value is provide us the value e that we know. We have proved this one in our previous video also. So e value lies always between 2 and 3. That means we can say e is greater than 1 always, as the value for the limit is greater than 1. So we can say the given series is divergent. So after doing all this, it comes in our mind that if we know comparison test, then what is the necessity to know D'Alembert's ratio test? Actually, all the time we can't apply comparison test to find out the nature of the series. Sometimes we require some other type of investigations also. So if when actually we apply this D'Alembert's test, now we should know that if un involves any power of n or involves any factorial of n, then we shall not apply comparison test. Rather, we try this time the D'Alembert's ratio test. Not only that, if a given series involves increasing power of x, then also we should apply the D'Alembert's ratio test. So actually when we apply the D'Alembert's ratio test for, we should do few more examples so that we can understand much better. So suppose your question is like this one. The series is 1 plus x by 2 plus x square by 5 plus x cube by 10 plus dot dot dot. So this one, just look here, the series terms involving the x value and which is an increasing power of x. If this type of series we will find out, then we should try with the D'Alembert's ratio test to prove the nature of this series. So here at first we should find out the nth term, that is un. So un should be what? Just observe the terms. So here if we consider un is equals to, first of all we consider the denominator. So it is n square plus 1. Then it is x to the power n if we consider. If we substitute one value here, then what we will find out? That it is 1 plus 1. So it is 2 and it is x only. So that we will get this term. So what we will do here, we just exclude the first term, because we know from the fundamental theorem of series, infinite series, that inclusion and exclusion of few terms in a series will not change the nature of the series. That's why excluding first term we started here. So the first term we say it is x by 2. So when n is equals to 1, then we will find out x by 2. When n is equals to 2, we will find out it is n square means 4 plus 1 5 and x square. So that we will get this term. When n is equals to 3, we definitely get x cube by 10. So this one is our un. So after getting this one, we should find out un plus 1. So just replace n by n plus 1, we will get this n plus 1 term, and then we will take the ratio and its limit. So limit n tends to infinity, un plus 1 divided by un is equals to this one. We just substitute this value, and after that if we simplify, then we will find out here it is n square plus 1 divided by n square plus 2n plus 1 into x. So if we divide both sides, that means numerator, denominator both by n square, then we will find out it is 1 plus 1 upon n square divided by 1 plus 2 by n plus 1 by n square into x. So if we take the limit, then definitely this all three are 0. So finally we will get the value is x. So hence from this one we can conclude that by D'Alembert's ratio test, the given series is convergent if x value is less than 1, and the given series is divergent when x value is greater than 1. But we can't say anything if x is equals to exactly 1. So for x is equals to 1, the series is convergent or divergent. That we have to check. And for this checking, let us do the following. So when x is equals to 1, that time what happened? X value becomes vanish. So our un becomes 1 divided by n square plus 1. So for this un, we now apply comparison test. So what we will have here, un is given 1 divided by n square plus 1. So comparison test means we should find out another series. With respect to that, we should compare the given one. So as here the denominator have n square and numerator have the power of n is 0. So the difference between the power is 2. That's why we should consider the series Vn is equals to 1 by n square for comparison, so that we can compare these two. Now from the comparison test we know limit n tends to infinity un by Vn. So that one, if it is a finite value, then it is depending upon the Vn, it is convergent or divergent. Anyways, here it is limit n tends to infinity. If we substitute all this, and after substituting the limiting value, we will find out the limiting value is 1, which is a unique finite value. Again, we, according to our choice, Vn, summation Vn, this series is summation 1 upon n square, which is definitely a convergent series, being a p series with p value is 2, which is greater than 1. Hence, by comparison test, we can say the given series is definitely convergent. Thus, the given series is convergent when x is equals to 1. So, finally, we can conclude that the given series is convergent when x is equals to less than is equals to 1. Because from the D'Alembert's ratio test, we will find out when x is equals to less than 1, the series is convergent. And for x is equals to 1, by comparison test, we will find out the series is convergent. So, we can say the series is convergent when x is less than is equals to 1 and divergent when x is greater than 1. Now, one more question let us discuss, that is discuss the convergency of the positive term series, this one. Here the series is 1 divided by 2 into root 1 plus x square divided by 3 into root 2 plus x to the power 4 divided by 4 into root 3 likewise. Here the un is what? Here un is first denominator, it is n plus 1 into root n, and in the numerator it is x to the power 2n minus 2. So if we substitute the value of n is equals to 1, we will find out this first term. If we substitute 2, we find out the second term, and likewise. After getting this one, again we should find out un plus 1. So that is just by replacing n by n plus 1 in this un, we will get this un plus 1. Now again we should find out the ratio for this one. So un plus 1 by un is equals to this one. If we simplify, we will get this. So after that, if we take the limiting value on this, then we will find out it is x square only. So hence, by D'Alembert's ratio test, the given series is convergent when x square is less than 1 and divergent when x square is greater than 1, and definitely test fails when x is equals to 1. So when x is equals to 1, then the series is divergent or convergent, then that again we go for the comparison test to find out this conclusion. So if x square is equals to 1, that time your un becomes 1 divided by n plus 1 root n. And let Vn is equals to 1 by n to the power 3 by 2. That is because just concentrate on the complete power of n here. So here the denominator having the power here, n's root over of n means half, and here n means 1. So 1 plus half means 3 by 2. And this power is 0. So the difference is 3 by 2. That's why we consider Vn is equals to 1 upon n to the power 3 by 2. So hence by comparison test, if we take un by Vn, this ratio, and its limiting value, then it is 1, which is a finite quantity. Hence the given series is convergent, as we will know that this our chosen series is a p series with p value is 3 by 2, which is greater than 1, and p series always convergent when p value is greater than 1. Thus, we can say, or we can conclude that the given series is convergent if x square is less than is equals to 1, and divergent if x square is greater than 1. So I hope you understand what is D'Alembert's ratio test and when to apply this one. But remember, it is not necessarily always to apply comparison test only if D'Alembert's ratio test fails. Rather, there are so many other tests also available like Rab's test, logarithmic test. That test also we can apply when D'Alembert's ratio test fails. Rather, here I am giving you few questions. For that, you should discuss the convergency and the divergency for the series. So just look at the series. First one is summation of n square divided by 3 to the power n. Second one is summation of n factorial by n to the power n. Remember, D'Alembert's ratio test should be applied when we have the terms involving in the series like n to the power n, n factorial, 3 to the power n. These type of terms, when it is involved, then we should apply the D'Alembert's ratio test. Not only that, if x in increasing power of x are involving terms, then we should apply the D'Alembert's test. So the third question is just look at it is 1 plus 2 to the power p by 2 factorial plus 3 to the power p by 3 factorial in this way where p is greater than 0. Fourth question is 1 plus 2 by 5 into x plus 6 by 9 into x square. Likewise, where x is greater than 0, it is given. And the fifth question is this one, 1 plus alpha plus 1 divided by beta plus 1, then plus of alpha plus 1 into 2 alpha plus 1 divided by beta plus 1 into 2 beta plus 1 in this way. So these are the 5 questions for you, and that is your do by yourself questions. Answer these 5 questions and write these answers in the comment box in this particular video. I am waiting for your reply. And I hope you understand D'Alembert's ratio test. Still, if you have any doubt, you may ask me in the comment box. So have a nice day and thank you all.